Hi, my name is Kiran Dev, and this is my presentation on predicting the wine quality using aggregation function in R. In this task, I basically analyzed the dataset of 1599 red wine samples to model wine quality using the aggregation function in R. Here I selected four input variables, then transformed the data, trained multiple models, and made prediction using the best performing functions. For the data distribution, I used histograms to visualize the distribution of each variables. As you can see from the image, the alcohol and sulfur dioxide are skewed and spread out. The quality scores are concentrated between the 5 and the 7, indicating mid-range wines are more common. These insights helped guided my transformation strategy in the next step. Next is the visualization. To explore how the input features relate to wine quality, I generated scatter plots for each variables as shown in the image. Here we can see that the alcohol showed the strongest positive relationship with quality, while sulfur dioxide had a negative trend. This analysis helped confirm which features were most predictive and support the variable selection in the next step. For selecting the variables based on the scatter plots and data distribution, I selected citric acid, chloride, sulfur dioxide, and alcohol as my input features. Here, the pH was excluded due to its weak correlation with quality. These four features were used in the rest of the analysis. In this step, I applied mathematical transformations to normalize the range and the shape of selected variables. This included log, square root, and power functions. After transformation, I scaled all the uh, features using min-max normalization, which ensures that the model treated each variable fairly and improved predictive performance. I tried to show the results through the screenshot. Here I used four aggregation models. First one is WAM, WPM with two powers, and last is OWA. These models were used same transform data and were run using a particular script, and the results were saved for the comparison in the next step. Then further I compared the models using error and correlation. WAM gave the best performance with the lower error and highest correlation, and the WPM model performed reasonably well while OWA showed weaker accuracy. So WAM is my best model as of now. Next is the model weight. The model assigned the highest weight to alcohol, showing it's the most important feature for predicting wine quality. Citric acid had some influence while chlorides and sulfur dioxide contributed less. These weights give clear insights into which variables uh, matters the most. Based on the learned weight, alcohol was the most important predictor of wine qualities. Citric acid and sulfur dioxide also contributed, while chloride had a small impact. This basically helps to prioritize the key factors that derive better wine quality. Best model. Out of all models, WAM gave the best results. It had the lowest error, highest correlation, and provide a stable prediction. Its simplicity and accuracy made it the most suitable model for our wine quality data. For predicting the input, I applied the same transformation and normalization to new wine sample. Using WAM, the model predicted a normalized wine quality of 9.96 as shown in the screenshot, which suggests that the wine would be rated very high in quality. Interpreting the prediction, the predicted wine quality of 9.96 is very high, but it aligned with our which aligns with our expectation. Input variables were favorable, especially the high alcohol content and low chlorides, which the model learned to associate with high quality wines. From the model, I found out that High alcohol and moderate citric acid lead to a better wine. Low sulfur dioxide also help to improve the quality, while chloride has the smallest effect. These these conditions align with real-world winemaking expectations. Coming towards the limitation, ethics, and privacy, there are a few important limitations. The model was trained on only 460 samples and it does not consider sensory data like taste or aroma. Also, this is a learning exercise not meant for commercial or health related issue use. No private data was used and ethical standards were maintained throughout. Overall, I used aggregation functions to predict wine quality from numerical features. The WAM performed best with alcohol having the highest impact, and the prediction matched our expectations. And the process highlighted how data preparation and modeling lead to a clear insights. These are the few sources and tools used during the analysis. Thank you.